In this video, we will talk about the mono robot. We will cover these topics in this video. The mono robot is a simple two-wheeled robot that is used for swarm robotic applications. Its linear and rotational velocities can be described by these two equations. We will first use open loop control to control the mono robot in our MATLAB simulation. Open loop control is not ideal in the real world as there is uncertainty in the real world caused by tolerances on components, changes in environmental conditions, and wear and tear over time on the system. As we can see, when we use open loop control with no uncertainty, the robot is able to perfectly trace the path intended. But if we include some uncertainty into the system, as we can see, the robot is unable to reach the target and veers off the optimal path. As a result, we switch to using closed loop control. In closed loop control, we use sensors to measure the output or the position of our robot, and then we feed that back to the controller. As we can see in this plot, the closed loop control performs much better. It is able to reach the final destination, although it does not use the optimal path. By better tuning our PI controller, we can make the robot be even closer to the optimal path than in this case. We will have a look at the error over time. So there are two different types of error. There's the error in the distance and the error in the rotation. The error in the distance is significantly higher than the error in the rotation. As a result, the gains for the rotational PID controller should be significantly higher than the one for the error. Also, both errors exponentially decay to a very similar value by the end. Combining all these methods together, we try form this M shape using the mono robot. As you can see, the mono robot does not follow an optimal path, but it does reach all of the appropriate checkpoints and forms an M that is clearly readable.